I'm Anil Kumar. This video is for my student Anna, who wants to understand about these terms which are related to direction and vectors. So there are actually four terms which you come across. One of them is called direction vectors. Then we have direction cosines and we have direction angles. They're not the same thing, right? They're different things. Right, so these are the terms which confuse some students at times. We'll also take up examples to calculate the direction angles and find a relation between the direction cosines. So that should give you a good overview of all these terms where direction is common in vectors, right? We'll stick to R3 for the time being. Okay. So let's first talk about direction vectors. What are they? So let me start from the very basics, and that is, what is a vector? So whenever I say a vector, it means two things. It has a magnitude and it has a direction, right? And that is what a vector is. So if I have a vector, let us say A, right, I could write this vector A as A1, A2, A3, right? Many times you've seen all this. It means what basically? Let us represent this in R3, right? So let's say that is our plane. Now, A1, A2, A3. So let's say A1 is kind of like this. Component along the x direction. A2 is, let's say, like this. The component along the y direction. A3 is kind of like this. Component along the z direction. You get an idea, right? So, if you have to really complete this box, you could actually first complete the base, right? Draw lines parallel, kind of, right? So, kind of like this. Okay, so let me just draw a few lines. Okay, so you get this box. Now, the vector which we are talking about is really from origin to this terminal point. So this vector is what we are talking about, right? So this is our vector A, correct? So I hope we are clear, right? So this is the vector A which we are talking about. And A1, A2, A3 are these components. So A1 is this much distance, that is A2, okay? And this here, which is also equals to that, is A3, which is also equal to that. Is it okay? The z component. So these are your components. These are scalar quantities. So that is how we represent a vector in R3. So this becomes our x-axis, this is y, and this is z. Perfect. That's the origin. So that is what a vector is. Now, we could always write this vector as combination of its magnitude and direction, correct? So we could say magnitude of A times, so if I factor this magnitude out, what I get here is the direction d1, d2, d3. That what remains, if I divide my vector by its magnitude, what remains is the unit direction. We also call this as a unit vector. So in a way, let me rewrite this. It'll be very clear. So if I divide my vector by its magnitude, it becomes what? It becomes unit vector. Does it make sense? I'm dividing the vector by its magnitude. So magnitude cancel, we get unit vector, right? So in this equation, what is this unit vector equals to? This unit vector will be d1, d2, d3. This is what I call direction. Is it okay? So this is the direction vector. Does it make sense? So when you divide the vector by its magnitude, whatever remains is a unit vector, and basically that gives you the direction of the vector. Okay, so in this particular case, that magnitude of 1 will give you the direction. Do you see that? It is in the same direction as the vector itself. Perfect. So this of unit magnitude is d1, d2, d3, which is the direction vector. So I hope that concept is clear to you, right? So first we have defined what is a direction vector, right? So this is your direction vector. Okay. Now let's talk about direction angles and direction cosines. Now as you can see in this particular picture, this vector makes angles with all the three axes. So it makes an angle, whatever angle it makes with the x-axis. So this angle with x-axis, we normally write this as alpha, right? So that is the angle it makes with the x-axis. And the angle which it makes with y-axis is termed as beta. And the angle which it makes with the z-axis is called gamma. These three angles are called direction angles, right? So let's talk about direction angles now. So direction angles are, you will note that it is only valid for a non-zero vector. That's important, right? It should have some magnitude. So we should mention, right? So direction angle of a non-zero vector, let's say A, in this case, non-zero vector A, are the angles alpha, beta, and gamma, which vector A makes with x, y, and z axis respectively, right? And this angle should be within 0 to pi, right? So this angle should be within 0 to pi degrees we're talking about. 180 degrees, I should say. I should not write this like 0 to pi radians, okay? Or you may say 0 to 180 degrees. Does make sense to you, right? So that is what direction angle is. Perfect. So direction angle is clear to you. Now what is direction cosines? Cosines of these angles, that is cos alpha, cos beta, and cos gamma. That is cosines of direction angles are direction cosines. Perfect. So that is how we relate all the three terms. Is that clear to you, right? So in a way, we have shown you what are direction vectors, what are direction cosines, and what are direction angles. Correct? Now we will see how to find them, right? We'll see how to find them. Now, shortcut methods I'm teaching you here. D1 is cos alpha, D2 is cos beta, and D3 is cos gamma. You will notice soon that unit vector could also be written as these direction cosines, which is cos alpha, cos beta, and cos gamma. Correct? So let's move on. So in the first part, we have learned all about direction vectors and how direction cosines and direction angles are related. Correct? So basically, direction angles, their cosines are direction cosines. Now let us see how to find the direction angles and what is the relation between direction cosines. So let me again sketch the R3 plane, and from there we will find the direction cosines. So let us say that this is our R3 plane, And the vector is kind of like this. Let's say that's the vector A which we are talking about. Okay. Now if you look into the let us say the y component, let's say y-axis, right? So this angle we are saying is beta. If I drop a perpendicular from here on y-axis, that means the projection of this vector A on y-axis, I will see that forms a right triangle. Now in this right triangle, the direction cosine is cos beta, correct? So we can say from here, what is cos beta equals to? Cos beta is equal to the adjacent side. Adjacent side is A2, right? The component of A along y direction divided by the magnitude of A. So that is, you can say the magnitude is this, right? Divided by the magnitude of A. So that becomes cosine beta. Does make sense to you, right? So what we are considering here is a vector A whose components are A1, A2 and A3. Perfect. So this is the component along the y-axis, which is A2. Cos of beta is A2 over hypotenuse. The magnitude is 1. Do you get the relation right? We could do the same thing with x-axis and z-axis and get the relation, which is cos alpha is A1 over magnitude of A and cos gamma will be A3 divided by the magnitude of vector A. Correct? So that is one way you could easily do it. Now there is an alternate way. Let's see how to find the relation of the directions. Let us see direction cosines. We'll see how to find direction cosines. So let me rewrite here direction cosines. Now we'll do it in alternate fashion. That is, you know what is the dot product. So if I'm finding angle which the vector A makes with, let's say, x-axis. With x-axis, we are saying the angle is alpha. Is it okay? So in that case, to find this, what we can do is, we can do the dot product of our vector with vector along the x-axis. So which is unit vector I. Now this dot product is equal to the magnitude of A times magnitude of unit vector I times cosine of angle between them, which is cos of alpha. Correct? Now let's find this dot product. What is this dot product? Well, the dot product is A1, A2, A3, dot I vector is 1, 0, 0, correct? So that should be equal to, magnitude is 1, we are left with magnitude of A times cos alpha, correct? So if you do this dot product, these two are zeros, so we are left with A1 equals to, let me write here, magnitude of A times cos alpha, correct? So from here, we can also get the same relation, A1 divided by the magnitude of A is cos of alpha. Do you see that? So we could also do with this A dot ijk, right, unit vector, and if you do that, what do you get? Cos of gamma, right? So you will get that magnitude of A when you divide into the vector, you get cos of gamma. Is that correct? So what you've seen here is that the direction cosines can easily be calculated by finding the ratio of their direction vector with the magnitude. Perfect. So that is how they are related, right? Now let me develop another relation. So we have proved this particular formula, that is cos alpha is A1 over magnitude of A1, cos gamma is A3 over magnitude of A, and cos beta is A2 divided by magnitude of A, where A1, A2, A3 are the components of the vectors along x, y, and z, correct? Now, what you can also check here is, how are these direction cosines related? Let's do that. That is cos square alpha plus cos square beta plus cos square gamma is equal to what? Well, we know what cos square alpha is. Cos square alpha will be A1 over the magnitude of A, right, whole square, plus A2 over magnitude of A whole square, plus A3 over magnitude of A whole square. Now that gives you clearly A1 square plus A2 square plus A3 square divided by the common factor magnitude of A square. And this indeed is 1, correct? So we have also shown that sum of squares of these direction cosines is indeed equal to 1. Perfect. So this is an extremely important formula which relates the direction cosines for any vector. Okay. Now based on this, let's take an example. Okay. So I'll take up an example where we will. Now let's take an example to further understand direction angles, direction cosines. So let us say that we are given direction angles alpha, beta, and we need to find the angle gamma, right? So let's say angle alpha is 65 degrees for us, let us say, right? And angle beta is 85 degrees. And we need to find what is angle gamma. Okay, so let the example be that you are given two angles, direction angles, and you need to find what is the third angle. That is the question for you. You can pause the video, answer the question, and then look into my suggestions. We just proved that cos square alpha plus cos square beta plus cos square gamma is equal to 1. So that relation can be used to find the third angle, right? So we can substitute here. So we get cos square of 65 degrees plus cos square of 85 degrees plus cos square gamma should be equal to 1. And we can isolate and we can write down that cos square gamma is equals to 1 minus cos square 65 degrees minus cos square 85 degrees, correct? So let's use the calculator, figure it out. So we have 1 minus cos of 65 degrees square. Let me first put the bracket. Okay, there's something wrong. So it is bracket square, and then we'll take away cos of 85 degrees, bracket close square. So that gives us, we get cos square gamma is equals to 0.81379. So what is cos gamma equals to? That is square root of 0.81379. Perfect. So let's find square root of this answer, which is 0.9021, right? So we get cos gamma as 0.9021, right? So from here we know what gamma is, which is cos inverse of 0.9021. So if I do shift cos inverse of our answer, we get 25.563. 25.563. Do you see that? So that becomes the angle for gamma. Correct? So if two angles are given to us, we can always find the third direction angle. Is that okay? So that is how you do it. Now let us extend this example, right? Let us find a vector with given direction angles. Okay, so we'll say alpha as 65 degrees, beta as 85 degrees, and I'll take gamma, I'll round this figure, right? So I'll take this as 26 degrees. Perfect. Now the question for you is, can you write a vector with these direction angles? Well, that's not difficult either. We can select the vector u have these direction angles. In that case, the vector will be cos of alpha, which is 65 degrees, cos of beta, which is 85 degrees, and cos of gamma, which is 26 degrees. That becomes a vector. In fact, this will be the unit vector. This will be the unit vector with given direction angles. Correct? That's what we learned initially, right? So now you can actually use your calculator, write down approximate values. So we could say u equals to cos of 65, which is 0.42, let's say 3, right? And then we'll do cos of 85, which is 0.087, and then we'll do cos of 26, which is 0.898. Do you see that? So we could get this vector as the one which has these directions. Perfect. You could actually multiply this vector by 100 or 1000 and write other values. So you could say the vector v could be, let's say 1000 times this. Let's say 423, 87, 898 will also be a vector with the same angles enlarged. Do you see that? So what we are saying here is that vector u is kind of like this, and vector v is like 1000 times, kind of like this. Do you see that? So it's in the same direction. So the direction angles are going to be exactly same. The magnitude will be 1000 times in this case. They are co-linear vectors. Perfect. So in a way, we actually understood with these examples what are direction vectors, what are direction cosines, what are direction angles, and how, if we know two direction angles, how to find the third one, and how could we calculate direction cosines, and from there we also saw how to find the vector itself. Is it okay? So I hope that gives you a fairly good idea about vectors, their directions, and direction cosines. Feel free to write your comments and share your views. If you like and subscribe my videos, that'd be great. Thank you and all the best.